What if I told you that everything you believe to be true is false, and that even the most modern ships are inferior to the technology of ancient Rome? It seems incredible, but the history of the greatest maritime power of antiquity holds secrets that still baffle even the most experienced engineers. We are talking about grandiose ports built in earthquake-prone areas. Phenomenal ships capable of turning a sea battle into a land battle, and the logistics that fed a vast empire. We are used to thinking that progress is always linear, but in some areas, the Romans achieved such heights that their impossible solutions are still relevant today. Modern shipbuilding and hydraulic engineering, despite all their computers and new materials, have not been able to completely replicate the durability and efficiency of those ancient systems. It's incredible but true. Technologies that are 2,000 years old still raise more questions than answers among experts. From powerful breakwaters capable of withstanding centuries of storms to unique hull designs that allowed them to dominate anywhere in the Mediterranean, the Romans were geniuses of marine engineering. They were able to solve problems that seem unsolvable to us today, using only the simplest materials and manual labor by our standards. These achievements were so stunning that they still amaze us with their boldness and functionality, remaining a mystery to today's researchers. Watch the video to the end to find out how the ancient Romans built ports that proved to be more durable than modern concrete structures, and why engineers still cannot fully replicate their secret. I will reveal the most closely guarded secret of Rome's great port structures, which is still the subject of study and debate among scientists and engineers. It is important to understand that Roman ports, such as Caesarea or Ostia, were not just moorings. They were grandiose engineering complexes that solved a problem that is still relevant to any marine construction today: corrosion in saltwater. While modern concrete begins to crack and deteriorate after only a few decades in a marine environment, Roman piers and breakwaters have stood for millennia, exposed to constant waves and salt. Are you ready to learn the truth about a building material that has proven to be virtually eternal? A key element in this success was the so-called Roman marine concrete, which was radically different from what we use today. This material was made from lime, volcanic ash called pozzolan, and seawater. Pozzolan, mined in volcanic areas of Italy, reacted chemically with lime and salt water in a unique way, creating an incredibly strong and durable binding agent. Interestingly, seawater, which is an aggressive environment for ordinary concrete, served as a catalyst for Roman concrete, making it stronger over time. The process of building port structures often began with the creation of underwater foundations using wooden caissons or double walls, which were then filled with this miracle concrete. There are known cases when builders dropped concrete blocks directly into the water, and it continued to harden under the influence of seawater, which was completely unthinkable for builders of other ancient civilizations. This approach allowed them to build huge piers and breakwaters in deep water and even seismically active areas, which would be extremely difficult even with modern technology. The Romans achieved that marine concrete not only withstood water, but actively reacted with it, forming mineral crystals that filled microcracks and prevented further destruction. Compared to modern Portland cement, which cracks due to the reaction of sulfates in seawater, Roman concrete formed rare alumite bermerite and philipsite, minerals that literally glued the concrete elements together, increasing its strength and density. Thus, the Romans not only knew how to build in water, they created a material that was in perfect harmony with the marine environment. Of course, their engineers did not have chemical laboratories, and all their knowledge was based on empirical experience and careful observation of nature. Take a look at the ruins of the port of Caesarea, which still stands partially in the Mediterranean Sea, to see this phenomenal engineering solution for yourself. The incredible durability of these structures has allowed them to withstand the elements for almost 2,000 years, while many modern breakwaters require constant repair and reconstruction. Their secret lay in understanding how to use natural volcanic materials to create concrete that surpassed all its counterparts in terms of its characteristics. Unlike the standard practice in other civilizations, the Romans were not afraid to build far from the shore, erecting giant piers that protected the port's waters from the strongest storms. It was these breakwaters that made it possible to create harbors capable of accommodating a huge fleet and merchant ships, supporting the empire's vital sea routes. The uniqueness of the technology lay in the fact that construction was carried out not only above water, but also underwater, which required incredible precision and organization. This entire system was part of a vast logistics network that the empire used to deliver grain, wine, oil, and other goods. Ports were not just mooring places, they were transshipment bases where cargo was quickly and efficiently redistributed. Even in this aspect, the Romans demonstrated their superiority by developing optimal loading and unloading schemes to minimize ship downtime. Their engineering solutions in ports were aimed at maximum functionality and durability, which allowed them to maintain uninterrupted trade and military supplies for centuries. This technology has not yet been fully replicated in modern conditions, and many of the chemical processes that took place in Roman concrete remain a mystery to scientists. Only recently have researchers begun to understand the true nature of these long-term reactions, which may change our understanding of marine construction in the future. It is amazing how, without complex calculations and modern equipment, the Romans created a material that was more environmentally friendly and more resistant to the elements. This is what happens behind the closed doors of scientific laboratories. They are trying to unravel the secret of Roman cement in order to create stronger and more durable structures for our time. This example shows that sometimes the past can give us the keys to solving the problems of the present. Roman port engineering is not just history, it is a textbook on how to build in harmony with nature. We are very interested in hearing your point of view. What do you think about the durability of Roman buildings compared to modern concrete? Write about it in the comments. And be sure to subscribe to our channel so you don't miss the next episodes dedicated to the incredible mysteries of the past. Want to know the secret that changed maritime dominance in the Mediterranean in just a few years? The tactics of the Roman fleet were initially weaker than those of the Greek and Phoenician maritime powers, which relied on maneuverability, complex formations, and devastating ramming attacks. The Romans did not have such a rich tradition of shipbuilding and often lost in pure naval combat, which required high speed and crew skill. Their strength lay elsewhere. They turned naval combat into a land battle in which they were unmatched. To do this, the Romans developed an incredible engineering solution called the corvus, or crow's beak. It was a movable boarding bridge equipped with a huge spike at the end that was dropped onto the deck of the enemy ship. This device was an ingenious response to the Carthaginians' superiority in maneuvering and ramming attacks. The corvus completely changed the rules of naval warfare, becoming a kind of time machine that transported the land legion directly onto the enemy's deck. The secret of its design lay in its functionality and ease of use. The corvus was a long, narrow bridge with a high perimeter that was attached to the bow of a Roman ship and could be raised and lowered using a complex system of blocks and ropes. When approaching an enemy ship, this bridge was lowered sharply, and a heavy metal spike, resembling a crow's beak, pierced the enemy's deck, firmly locking the ships together. Once the ships were locked together, Roman legionaries trained in land combat simply ran across the bridge onto the enemy's deck. For Carthaginian and Greek sailors, who were not heavy infantrymen, this was a disaster. Their crews, consisting mainly of rowers and lightly armed throwers, could not withstand the disciplined and well-armed Roman infantry. This technical innovation completely negated all the tactical advantages of the Carthaginians. The invention of the corvus was so effective that it allowed Rome to win the First Punic War without initially having a strong fleet. The first major battle in which the corvus was used, the Battle of Milas in 266 BC, ended in a complete defeat for the Carthaginians. They simply did not know how to counter a tactic that turned their fast, maneuverable ships into immobile platforms for hand-to-hand combat. However, the corvus had a significant drawback, which ultimately led to its abandonment. Due to its considerable weight and high position, it made the ship unstable, especially in heavy storms or during maneuvers. Several Roman fleets were lost during storms, and historians believe that the corvus was the main cause of this increased accident rate. Nevertheless, it fulfilled its purpose. It gave the Romans temporary superiority and allowed them time to master classical naval tactics. Despite its short life in the history of the Roman fleet, The corvus remains a shining example of engineering ingenuity. It demonstrates how Rome was able to adapt its strengths, namely its superior infantry, to solve problems in a completely new field. It was not just a weapon, but a true symbol of the pragmatism and ingenuity of Roman engineers. Even today, in the age of missiles and aircraft carriers, the concept of turning a naval battle into a controlled boarding remains unique. This mechanism changed the course of history, allowing a land power to become the ruler of the seas. But knowledge of the terrain was only half the battle. Ready to learn how the Romans created the perfect ship, combining the speed of a Greek vessel with the strength of a Roman one? You've definitely never heard of this unique secret. The Romans weren't great shipbuilders at first. Their fleet was basically built from designs they copied from captured Carthaginian ships. However, once they mastered the foreign technology, they began to improve it, creating ships that perfectly suited their military and logistical needs. The result was a Roman warship that combined the high speed necessary for pursuit with the incredible strength needed for boarding combat. The key type of ship was the quinquereme, a vessel with 5 rows of oars, which was heavier and more stable than its Greek counterpart, the trireme. The Romans emphasized hull strength, using thicker wooden beams and more reliable fastening methods. This allowed their ships to withstand powerful ramming blows that could sink more fragile enemy vessels. At the same time, they did not completely sacrifice speed, using optimized hull shapes in a large number of rowers. The uniqueness of the Roman approach lay in standardization. After copying the Carthaginian model, they quickly established mass production of these ships. This was not just construction, it was the first industrial assembly of a fleet in history. Huge shipyards operated like conveyor belts, allowing them to rebuild their fleet incredibly quickly after losses and compensate for any damage caused by the enemy or the elements. It was this ability to quickly replenish losses that became their strategic advantage. Their warships, galleys, were designed to have enough space to accommodate a large contingent of legionnaires ready to board. Unlike Greek ships, where the main weapon was a ram, Roman ships were essentially floating platforms for infantry. They even had their own artillery, ballistas and scorpions, throwing machines that fired large arrows and stones, clearing the enemy's decks before boarding. In addition to military galleys, the Roman fleet included a huge number of transport ships, which formed the basis of their maritime logistics. These cargo ships, or cogs, were wide, rounded, and very spacious. They were not fast, but they could carry huge quantities of grain from Egypt, oil from Africa, and marble from Greece, which was vital for maintaining the empire. They also developed unique vessels for special missions, such as patrol ships, which were lighter and faster, or reconnaissance vessels. This diversity of the fleet allowed them to effectively perform both military and civilian tasks, ensuring the safety of sea routes and uninterrupted supplies. This comprehensive approach to the fleet, which included standardization, rapid assembly, and a variety of ship types, was unique in the ancient world. Surprisingly, Roman shipbuilders achieved such a level of understanding of hydrodynamics that their ships were both sturdy and fast enough to dominate the seas. They did not invent the sail, but they perfected the hull design, which could carry a huge number of people and weapons. It was not just a ship, it was an instrument of imperial power. This tactic demonstrated a fundamental difference in military thinking. The Greeks and Carthaginians thought in terms of maneuvers and ramming attacks, while the Romans thought in terms of delivering infantry to the enemy deck. Their strength lay not in the beauty of their sails, but in the power of their legions. Thus, the Roman ship was not just a means of transport or a floating fortress, but a well-thought-out tactical weapon. It turned a naval battle into a land battle, where Rome's advantage was undeniable. Did you like this unique detail? Then don't forget to like this video. It helps us find even more incredible historical facts for you. And be sure to subscribe to the channel so you don't miss any new videos. What you are about to learn will change your perception of ancient naval battles. Initially, the ram was the main weapon in naval combat, requiring the highest skill of the rowers and perfect coordination of the crew. The Greeks and Carthaginians perfected this tactic by building light, maneuverable ships with sharp, reinforced prows capable of piercing the side of an enemy ship. The Romans, lacking such traditions, were forced to seek their own, more straightforward approach. The Roman ram, or rostrum, was an engineering marvel designed to crush rather than simply pierce. It was made of heavy, durable wood and often reinforced with powerful bronze or copper plates. Unlike the razor-sharp rams of Greek triremes, the Roman rostrum was blunt, massive, and multi-toothed. Its purpose was not simply to pierce the hull, but to inflict maximum structural damage. The strategy was simple. Thanks to its sturdy construction, a Roman ship did not seek to avoid battle, but to engage in it, withstand the blow, and then deliver a more devastating counterattack. The multi-toothed rostrum acted like a giant can opener. It rammed into the enemy's side, not piercing it completely, but tearing off huge pieces of plating and breaking the internal ribs. This led to severe flooding and quickly put the enemy ship out of action. Moreover, Roman engineers used the ram not only as a weapon for sinking ships, but also as a tool for forced boarding. If an enemy ship was badly damaged but remained afloat, the Romans could use the rostrum to hook onto it and hold it in place until the legionaries crossed over on the corvus. This allowed them to control the situation and decide whether to sink the ship or take its crew prisoner. In addition to the rostrum itself, the Romans actively used catapults on their ships, as mentioned earlier. Ballistas and scorpions fired at the enemy's deck, neutralizing rowers and archers. This tactic, first softening up the enemy with projectiles, then inflicting structural damage with a ram, and finishing the battle with boarding, was complex and incredibly effective. The Romans also did not neglect the use of bulwarks, which were higher than those of most Mediterranean ships. This gave their infantry an advantage in height when throwing javelins and defending against enemy arrows. Their ships were veritable floating fortresses, where every element of the design served the purpose of combat with maximum efficiency. Thus, the Roman ram was not just a sharp nose. It was part of a complex tactical system where engineering worked for strategy. Their ships were designed to take a hit, stay afloat, and deliver a decisive counterattack. It was a direct embodiment of Roman pragmatism at sea. As a result, naval battles with the Romans became a real nightmare for their opponents because they could not use their traditional tactics. They were facing not just a fleet, but an army that knew how to fight on water. Which of the two options do you think is more effective? A maneuverable and fast ram or a heavy and devastating Roman rostrum? Roman engineering solutions often required construction in the most unfavorable conditions, and underwater foundations are a prime example of their ingenuity. This includes not only ports, but also bridges, aqueducts, and even baths that were built on or in the water. This invisible part of their legacy was critical to maintaining the empire's entire infrastructure and is still admired for its durability. The main problem with building in water is the need to drain the work site or ensure that materials can harden underwater. For construction at shallow depths, the Romans used wooden structures called cofferdams or caissons. These were watertight boxes or double walls made of logs and planks that were driven into the bottom and then pumped out of the water using primitive pumps or buckets. After drainage, the worksite became accessible for pouring the foundation from the aforementioned waterproof concrete. This method allowed them to erect stone bridge supports and huge foundations for port structures on dry ground, ensuring incredible strength and stability of the structure. It was a complex and laborious task that required perfect water tightness and the coordinated work of hundreds of workers. For deeper waters or where cofferdams could not be used, the Romans relied on the method of dropping concrete blocks. Huge wooden molds were filled with marine concrete and dropped into the water from barges. The concrete slowly hardened underwater, forming an artificial reef or foundation for the future structure. This method was less precise but allowed for the construction of massive underwater foundations, even in the open sea. Interestingly, when building bridges, especially those crossing wide and fast-flowing rivers, the Romans often used a system of temporary dams and diversion channels. They could redirect the riverbed, drain part of the bottom, and build supports on dry land, then return the river back to its bed. This demonstrates not only their engineering skills, but also their remarkable ability to manage natural resources. They also used pile foundations, especially on soft ground. Wooden piles, often made of oak or alder, were driven into the bottom using hydraulic hammers and winches. The piles, being constantly underwater, did not rot and served as a reliable foundation for further construction, which was critical for the durability of many coastal and river structures. These invisible foundations were the cornerstone of the entire Roman infrastructure. They allowed the empire to build where other civilizations saw insurmountable obstacles. Their approach to underwater construction was pragmatic, innovative, and, most importantly, incredibly effective in the long term. Having mastered construction on land, the Romans conquered the water element with the same tenacity. Here's an interesting question. What if I showed you a system that was more efficient than modern supply chains? Rome's military victories and prosperity would have been impossible without its ingenious maritime logistics system. This system, known as the annona, the state food supply program, relied on the navy and a developed port infrastructure to provide food for the huge city of Rome and the entire army. Unlike other empires that relied on land routes, Rome bet on the Mediterranean Sea, turning it into its internal waterway. A key element of logistics was grain supply. Every year, huge fleets of merchant ships, or naves granaria, transported millions of tons of grain from the empire's granaries, Egypt and North Africa, to Ostia, Rome's main port. This constant and uninterrupted flow of food was vital not only for feeding the citizens, but also for maintaining social stability. A lack of bread could lead to riots, so grain logistics was a matter of national security. To ensure this logistics, the Romans developed specialized cargo ships called cogs. These ships, as already mentioned, were wide and spacious, with a deep draft, which allowed them to carry huge volumes of cargo in their holds, often packed in standard amphorae. The use of standardized containers allowed ships to be loaded and unloaded quickly and efficiently, which was critical to the speed of delivery. The port of Ostia, and later the port of Portus, specially built by Emperor Trajan, were the pinnacle of logistical engineering. They had a complex system of basins, canals, and warehouses that allowed them to receive and service many ships at the same time. These ports had a whole system of warehouses, aurea, which were designed to protect grain from moisture and pests, ensuring its long-term storage. In addition to food, maritime logistics also supplied the army. Military ships called longi were used to patrol sea routes and protect merchant ships from pirates. Transport ships also carried legionnaires, horses, weapons, building materials, and even entire siege engines. The ability to quickly move large military contingents by sea gave Rome a huge strategic advantage over its enemies. Managing this complex system required detailed planning and administration. Behind it all was a state bureaucracy that monitored ship schedules, inventory levels, and the safety of sea routes. Roman logistics was a true art of resource management on an imperial scale, which still amazes with its efficiency. This system was so well-oiled that it could withstand natural disasters, recover losses, and continue to function even in times of military conflict. It was the quintessence of Roman pragmatism, using the power of the fleet to support not only military ambitions, but also the daily lives of millions of citizens. Logistics was not just a process, it was the lifeblood that nourished the heart of the empire. The ambush was effective, but how did the Romans use their technical knowledge to build not only on the surface, but also deep underwater? In the next chapter, we will talk about their unique underwater foundations. Roman dominance at sea required not only powerful ships and advanced ports, but also a reliable navigation system. In an era when sailors had neither radar nor GPS, they had to rely on the stars, experience, and primitive instruments. Lighthouses became the main landmarks, showing the way in the dark and warning of dangers. These structures towered over the coastline and commanded respect from all who saw them from afar. They served not only practical purposes, but also demonstrated the power of the state. For centuries, they illuminated thousands of kilometers of sea routes. At that time, a lighthouse was much more than just a fire at the top of a tower. For captains navigating their ships along unfamiliar coastlines, it became a beacon of hope. The light of the lighthouse meant the proximity of a port, the opportunity to find refuge and avoid treacherous reefs. Lighthouses helped save the lives of sailors and prevented ships from wrecking, which could have resulted in huge losses. Therefore, the construction of such structures was considered a matter of state. Through them, Rome strengthened its control over sea routes. The most famous lighthouse of antiquity was the Lighthouse of Alexandria. Although it appeared during the Hellenistic period, the Romans actively used it and kept it in working order. Its height and power inspired Roman engineers to create their own lighthouses. The Lighthouse of Alexandria became the standard that all major ports tried to match. Its light was visible for tens of kilometers, making it a true marvel of engineering. It became a model that was imitated in many regions of the Mediterranean. The Romans built many of their own lighthouses, called farum, throughout the Mediterranean. They appeared at strategically important points where trade and military routes converged. Even distant Britain received such structures so that Roman ships could navigate the foggy coast. Each lighthouse was part of a vast network that connected the empire's possessions. Thanks to this, Roman ships could move confidently even in difficult conditions. Lighthouses became symbols of stability and order. The construction of these lighthouses was monumental and fully in line with the Roman style of building. They often took the form of multi-tiered towers rising above the surrounding landscape. Durable stone and marine concrete, which could withstand salt water and storms, were used for construction. Roman architects carefully calculated their height so that the light could be seen from the maximum distance. Such structures could stand for centuries thanks to the quality of their construction. They became part of the urban landscape and the pride of local residents. The multi-tiered design made the lighthouses stable, allowing them to withstand the force of the wind and waves. The lower tiers served as storage rooms and living quarters for the service personnel. The middle tiers were used for observation and storage of tools. The top tier was dedicated to the main function of the lighthouse, emitting light. Each level was built with load distribution and durability in mind. That is why many Roman lighthouses have survived, at least partially, to this day. At the top of the lighthouse was a system of mirrors or polished metal plates that amplified the brightness of the fire. This allowed for increased visibility without significantly increasing fuel consumption. The lamp was fueled by wood or oil, depending on the region and available resources. Maintaining the fire was the task of an entire team that worked without interruption. They monitored the wind, cleaned the mirrors, and checked the strength of the structure. The work was hard but vital for all sailors in the area. Maintaining the lighthouse required strict organization and a constant supply of fuel. In some places, wood had to be transported over long distances, especially if the surrounding region was poor in forests. Oil was also expensive and had to be purchased in advance. The Roman authorities ensured a stable supply, understanding the importance of uninterrupted operation. Shifts were arranged so that the fire never went out. The lighthouse had to shine every day and every night, regardless of the weather. The Romans also improved the system of maritime navigation. They compiled detailed periplus, a kind of maritime description, in which they recorded the features of the coastline. These texts included the distances between ports, the presence of shoals and dangerous areas. The periplus were used by captains and passed down from generation to generation. They became the navigation reference guides of antiquity. Thanks to them, sailing became predictable and safe. Such descriptions were especially important for young sailors who were just beginning to master trade routes. Experienced captains supplemented them with new observations and clarifications, forming a rich tradition. They included data on currents, seasonal winds, and places where storms could be weathered. All this information transformed the sea from a chaotic space into a controllable environment. Rome managed to combine practical knowledge and state control. This allowed it to create an effective navigation system. Another key element was the standardization of sea routes. The Romans identified the main corridors that were considered the safest and most convenient for travel. These routes passed through proven ports where ships could obtain protection and food. Ships following these routes could count on the assistance of patrol ships in case of pirate attacks. This organization reduced risks and accelerated trade. Goods, people, and news from across the empire traveled along these routes. In addition to lighthouses, sailors actively used natural landmarks that were visible from a great distance. Steep cliffs, unusual mountains, and distinctive coastlines became important points along the way. Roman engineers sometimes even altered the landscape to make the coast more visible. They reinforced slopes or built special towers that helped distinguish one section of the coast from another. As a result, the entire Mediterranean coastline became a huge navigation map. In this way, the Romans turned the sea into a space completely subject to their rules. Maintaining a huge fleet in combat readiness required an engineering system that was no less complex than its construction. The Romans developed effective repair and maintenance methods that allowed them to quickly repair damage sustained in battle or from storms. It was this ability to recover quickly that gave them a strategic advantage. A key element in maintenance was dry docks, although these were not in the modern sense, but rather specially constructed pools. Large ports, such as portus, had systems that allowed ships to be brought into a protected basin and then drained using sluices or pumps. This made it possible to carry out work on the underwater part of the hull that would have been impossible while the ship was afloat. The most important work was carried out in dry docks, cleaning the hull of algae and shells, repairing the plating, and replacing damaged keels and rams. Cleaning the hull, or carining, was critical to maintaining speed. Algae could slow a ship down by up to 20%, so regular maintenance was a matter of combat readiness. The Romans also used slipways, sloping coastal platforms onto which ships were pulled for repair using winches and blocks. This method was simpler but required more manual labor. Slipways were often located directly in military camps so that repairs could be carried out immediately after the ship returned from a campaign. Floating platforms and barges were used for minor repairs and maintenance at sea. They housed workers and the necessary tools, allowing minor damage to rigging and sails to be repaired without taking the ship to port. This was especially important during long campaigns when it was not possible to return to a large base. The storage of the fleet was also an important aspect. During the off-season, especially in winter, many ships were pulled ashore to avoid wood rot and storm damage. Special hangars or sheds were used for this purpose to protect the wood from precipitation. This was part of an overall strategy of durability and resource conservation. All these engineering solutions were aimed at minimizing downtime and maximizing combat readiness. Rome's ability to quickly commission new ships and repair old ones was no less important than its tactical victories. Their fleet maintenance system was a true logistical feat that supported imperial expansion. One of the most insidious problems for any ancient port was silting. Rivers carried silt, sand, and gravel that settled in the calm waters of harbors, gradually making them shallow and unsuitable for large ships. While many ancient ports were abandoned for this very reason, Roman engineers developed ingenious solutions to combat this natural threat. One of the most effective methods was to build underwater walls or hidden barriers at the entrance to the port. These walls were located just below the water level and were invisible to the eye, but they performed a critically important function. They directed river currents and tidal flows in such a way that they bypassed the port area, preventing silt from settling inside the harbor. In some ports, especially those located at river mouths, the Romans used a system of flushing basins. These were huge reservoirs that filled with water during high tide. When the water level dropped, these basins were suddenly opened, and a powerful stream of water literally washed away the accumulated silt from the entrance channel and the port area. This system was difficult to manage but incredibly effective in combating silting. Another method was to build ports away from river mouths, as was done in Portus, which was connected to the Tiber by canals but was far enough away to avoid the main silt deposits. The canals themselves were designed to minimize sedimentation by using the optimal flow velocity. The Romans also used dredging, a process that was, of course, labor-intensive and manual. Workers used special scoops and baskets to manually remove silt and sand from the bottom of the harbor. Although this was inefficient by modern standards, regular dredging allowed the necessary depth to be maintained. The engineering of underwater walls was not just construction, but a deep understanding of hydrodynamics and geology. The Romans carefully studied local currents and tides to design their ports in harmony with nature, not against it. This allowed them to create harbors that required minimal maintenance and could serve for centuries. This concern for durability and functionality is a hallmark of Roman engineering. They did not build temporary structures. They built for centuries, and their solutions to silting are one of the most striking examples of this philosophy. Rome's military machine was insatiable, and its uninterrupted supply was made possible by masterful maritime logistics. For legions stationed in distant provinces, sea routes were the only way to obtain provisions, equipment, and reinforcements. This military logistics was so effective that it allowed successful campaigns to be conducted at great distances from the center of the empire. Unlike commercial logistics, military logistics were more urgent and required greater secrecy. Special transport ships were used for military supplies, which could be faster and, if necessary, armed for self-defense. They carried not only grain, but also wine, vinegar, which was an important part of the legionnaires' diet, and of course, a huge amount of weapons. A key factor was the creation of naval bases throughout the Mediterranean and Atlantic. These bases, such as Misenum or Ravenna, were not just mooring places, but complex centers where supplies were stored, repairs were carried out, and from where the fleet was commanded. They were strategically located to control key sea straits and trade routes. The supply system itself was standardized. Each legionnaire had a standard ration, and logisticians calculated exactly how many ships would be needed to supply a certain number of troops for a certain period of time. This precision in planning was unique for the time. Maritime logistics were especially important during conquests, such as the invasion of Britain or the war in Dacia. The fleet not only ensured the landing of troops, but also provided a continuous supply, allowing the legions to be independent of local resources and advance deep into enemy territory. Maritime transport was also a means of transporting large construction materials. The famous Roman stone, marble, and granite were all delivered to the empire's construction sites by sea. This made it possible to build luxurious cities and monumental structures, even in places where there were no local reserves of high-quality stone. This entire system was integrated with the land-based road network. Ports were the starting and ending points for the delivery of goods, which were then distributed throughout the empire via the famous Roman roads. Maritime and land logistics worked as a single, well-oiled machine. It was thanks to this complex and efficient logistics system that Rome was able to keep its army in excellent shape, even thousands of kilometers from home. This was not just luck, but the result of ingenious engineering and administrative work. We can see that Roman maritime engineering was not just a set of techniques, but a comprehensive and deeply thought-out system that allowed a land power to become the ruler of the seas. Their achievements, from the creation of eternal marine concrete and the ingenious corvus to the most complex systems of port logistics and navigation, still raise more questions than answers. The Romans did not just build ships and harbors. They created an infrastructure that outlived the empire itself and remains a testament to their engineering genius. The secret to their success lay in pragmatism, standardization, and a deep understanding of how to use nature rather than fight it. They turned volcanic ash into a material that water cannot destroy and adapted their military advantages to naval combat. Their legacy is not just a page in history, but a living lesson for modern engineers on how to build for the ages. Which of Rome's engineering mysteries do you find most ingenious and why? Was it the eternal marine concrete or the phenomenal port flushing system? Share your opinion in the comments and don't forget to subscribe to our channel so you don't miss out on new research into the military tricks and engineering feats of the past.